Okay, so here's a little more information on figuring out range and domain from a graph. So let's just draw something here. Just do quadratic functions. Comes down like that, comes back up to here, and let's assume this goes from -10 to +10. Our x-axis, and this is our y-axis. So the domain is the values of x for which this function exists. So if I draw a vertical line here, what I'm looking for is where does the function exist. So if there's no intersection with the curve or the function, then the function does not exist in the x direction. So up until I get to x equals -5, which is here, function does not exist. And because there's this empty circle, we're saying the function does not exist at x equals -5, but it exists anywhere to the right. So we can, the function is existing. You can see this line, vertical line intersecting it. And then we come over here to the other side of the interval, which is +4. So if I wanted to know what the domain of this function is, I would say that the negative side, the left side, starts at -5 but does not include -5 because of this empty circle. Then you put a comma and then you see where the function exists towards the positive side, and we have 1, 2, 3, 4, so it's +4. But because I have a solid dot, then I put a square bracket. So that's interval notation. Looking at it as inequality, I say that x is greater than, not equal to -5. And on the other side, say that x is less than or equal to 4. So that would be one way of doing it. I guess you could do it the other way around. X is greater than 5. That's probably a better way to do it. Less than or equal to 4. Usually you have the more negative number here. Okay. Oh, let's look at the range while we're at it. So the range is the y values that exist for this function. So what I'm going to do is draw a horizontal line. So you can see that the maximum value that this function exists at is, or the value of the function that it takes on in the y direction is +5. Now it doesn't actually equal +5 because it's a hollow circle there. And then as we go down, you see the function is existing over here. Now it's existing two x values, but one y value. And we come down here to where we have our minimum, which is at y equals 1, 2, 3, 4, -5. So again, in interval notation, the range would be from -5, so we'll take the most negative thing. Now, because the function does have the value -5, we can put in a square bracket, put a comma, and then the maximum y value is actually up to +5, but doesn't include +5, so we'll put a curved bracket like that. So again, what I'm showing here is that the function's minimum value in the y direction is -5. 1, 2, 3, 4, 5. And then it goes up to here. So it's not equal to 5, but it's up to 5. So that's how we would do that. And the way you would write that inequality is that -5 and do that. So here we're saying it's equal to -5 up to +5, but not including +5. Okay, let's think of another one here. So let's put a solid dot here, and it goes down that, back up to here. Okay. So again, if we draw a vertical line, you see at 1, 2, 3, 4, less than -4, the function does not exist, but then it starts to exist. The x value, the function exists there because there's a corresponding y value. And we go over here, and we would, at greater than x equals +3, the function does not exist anymore. So it's between x equals -4 and +3. But because we have dots here, it includes the endpoints. So the domain would be -4, 3, and we'd have square brackets on both sides. If we were to do the same thing, so we just take this same graph, put it on here, something like that. I don't remember how high that thing went, to 5. There we go. And if I need to get rid of that dot, so if I had open dots there like that, so the domain for this function would be from 1, 2, 3, 4, so it's -4, 1, 2, 3, +3, but we have curved brackets on both sides instead of square brackets. Now, as far as the range is concerned, we draw a horizontal line, and you can see that, you know, as we approach 0 from the negative side, the function starts to exist here. Y equals -4, and it's going to equal -4. That's not the endpoint, it's in between the endpoints. So it's going to be -4, comma, and then we move it up to here, and it reaches a maximum of +5 in the y direction, and it equals -5 because it's solid dots. Whereas over here, the range is going to be similar. The lower limit, 1, 2, so that's -4, but the upper value is 5, but because it never actually equals 5, we'd have to put a curved bracket like that. Now, if you have a function that's something like this, and let's say it goes like that, and then you show an arrow, what that's meaning is that line continues to go, and it's going to go +x and -y. Let's say it starts right here. So the domain are the possible x values. So if I draw a vertical line, you see that less than -4, the function does not exist. The function does exist at -4. And then it'll keep going, it'll go forever. So the domain here is going to be from -4, including -4, so put a square bracket. And then on the right hand side, it'll go out to +infinity. But it never equals +infinity. Now to do the range, look at a horizontal line. So this endpoint here has nothing to do with the range because it's between here and -infinity. So we take out where the maximum value is, which is at +8. So, and it is equal to +8 because it's the function, so I'm going to put a square bracket of 8. And then this line can go all the way down to negative infinity, but it doesn't include negative infinity. And we'll do one more. So let's start somewhere like here. Circle. And then we'll just go down like that. So again, this arrow means it's going to go on forever, both towards negative infinity here and negative infinity there. So our domain, if we draw a vertical line, see the function does not exist at greater than x equals 5. So at x equals 5 we actually start just less than x equals 5. So the domain is going to go from the maximum value is negative 5, positive 5. Doesn't include 5. And then it'll take on any x value to negative infinity, but it doesn't equal negative infinity. And the range perspective, draw a horizontal line here, you can see at greater than y equals 7, the function does not exist, but it comes down to 7. It starts just below 7, and then it goes down to negative infinity. So the range will be from negative infinity to positive 7, not including 7. So hopefully that helps.